And Thorsten, the stage is yours.
Yeah, thank you, Rainer. So, as Rainer already mentioned, today I will give you a quick introduction into Crustlet, what it is, and why you should care about it. So first of all, quick introduction to myself. My name is Thorsten. I work as a consultant in Germany with ThinkTexture. My main focus is cloud native and Kubernetes. And if I speak about public cloud in the context of cloud native, it's almost always Azure because I have a deep or long history with Microsoft. And another key focus area of mine is Terraform, so infrastructure as code. I've been diving into Rust, let's say a couple of months ago. I really enjoy it. It's really refreshing, to look into different languages. And at some point, I stumbled upon Crustlet, and that's why I invested a lot of time in the last weeks or so to dive deeper and to see what's possible and what's not possible yet. So if you have any questions about those topics, don't hesitate, just ask. So either shoot me a mail or reach out on Twitter. I'm happy to help. All right. So basically, I've divided the talk in three small main sections. So first of all, we do a quick introduction, why WebAssembly beyond the browser. Then we will look at Crustlet, what it is, and how you can get it, how you can get up to speed. And then we will take some very, very basic WebAssembly workloads and run them in a Kubernetes cluster. Okay, with that said, let's jump into the topic. So WebAssembly obviously was in the browser at the first place. So we were able to compile against WebAssembly, take a WASM module, load it in the browser, and execute code that was not intentionally written for the browser as a platform. But there were movements to bring WebAssembly to other platforms, so going beyond the browser. And back in 2019, I guess there was the idea of coming up with a system interface to unify how our code compiled against WebAssembly or against that new interface called the WebAssembly System Interface, or short WASI, will interact with the underlying operating systems. Because the idea is, I think it was Java back in the days that came up with that promise: write once and run everywhere, and that promise still has to be fulfilled somehow. And my guess is that WebAssembly with WASI, with WebAssembly System Interface, is able to achieve that. So we have WASI as the platform that we can compile to, and then WASI takes care about all the underlying operating system specificas, like how files are handled, how network interaction is done, and so on and so forth. So that's kind of the underlying idea of going beyond the browser with WebAssembly. And obviously there are multiple WASI compliant runtimes available. WASM time is perhaps the most popular or the most well-known one. But there's also WASMer, which is actually written in Rust, which implements all the WASI specification. So if we break it down, okay, why should I consider compiling my Rust application against WebAssembly as a platform and then running that one on the server or in the cloud? Well, obviously it's portability. I mean, if we compile against WASI instead of compiling against Darwin, Linux, or Windows, for example, we end up with having a single binary, right, that we can take, throw it over the wall and get it executed by a WASI compliant runtime, no matter which one it is and no matter who's operating that one. So is it in, perhaps the cloud vendor is in charge of, ensuring or operating or taking care about the runtime being as efficient as possible. So, or it is me. So there are a bunch of, I would say, CLIs or applications already leveraging WASM time or WASI as its runtime. So we download the actual application as a WASM module, and we are using WASM time to invoke it. So portability is one of the main whys why we should care about WebAssembly beyond the browser, and the other one is security. And I've taken, to explain portability and security, I've taken some of the pictures from one of the first blog posts or articles written about WASI. So the link is in the slides, and I will share the slides obviously after the talk. So portability, as I already said, we compile against the WASM32 WASI platform, and then we will end up with having a WASM module, which we can then run by leveraging WASM time, for example, on Linux, on Windows, or on macOS. So yeah, for us, it's easier. We just have that one distributable as an application developer that we must provide. And we have the guarantee, right, that the underlying runtime takes care about interacting with the operating system. The more interesting aspect, or the more interesting why, is obviously security, right? So if we take a look at how applications get executed traditionally, is we have something. So we have the kernel, right, the operating system with all its APIs, and then we have the so-called user mod. So that's where I execute applications, and those applications typically interact with the operating system APIs by issuing system calls in behalf of my user account. So what typically happens is an application say, "Hey," as written on that picture here, "Hey, I got invoked, or I'm running in the user mode of Alice, and can you please open that file, right, or that directory in that case?" And the underlying operating system checks, okay, does Alice have the permission to open that directory? And if so, it hands over, or it allows the application to read the directory or the files in it directly. That's how it works today, right? So you can think of if you're familiar with open authentication too, for example. In open authentication, we have a user and we have a client, so the application, right, that we are actually using. And in the traditional mode, how applications are executed on an operating system, we are lacking control over the application somehow. So the application always talks with the operating system in behalf of the user. So a malicious application could ask the operating system, "Hey, can you open that Bitcoin wallet for me?" and provide the path to that Bitcoin wallet on the logical disk or on the physical disk. The operating system checks if the user Bob has permission to that file. Yes, he has. So it opens up it allows the application to open that file. And as you can see, now the malicious application or risky app asks for a network connection, which, well, obviously, if Bob has that permission to talk over TCP, for example, then the application could send all the contents of the wallet to a remote server or so. So, and that's a problem that we were facing today, right? Especially if we have applications becoming complexer and complexer, and we're bringing in third-party dependencies, which typically or recently led to a way more vibrant discussion about DevSecOps, right? About scanning third-party dependencies and to see what actually is part of an application. But with WASI, so with the WebAssembly system interface, what we can do there is, so a WebAssembly module is always sandboxed, right? So the sandbox itself, we can let's say whitelist certain APIs. So for example, if we come back to the sample of doing some kind of file access, well, that may be allowed. So maybe we say, okay, hey, risky app, you're able to read, let's say, the user folder and all its content. Okay, so the operating system will allow the application to read the files. However, if we not allow that risky app to do any kind of network communication, then the WebAssembly runtime, so fuzzy time in that case, won't allow that particular application to do that, to access the underlying network infrastructure, right? Where on the other side, for example, the trusted app that may get granted the permission to take or to communicate via network, but the app doesn't need any kind of local file system interaction, so it may not have the permission to read the file. So basically, WebAssembly and Fuzzy would allow us to define permissions based on the actual application, which is a good thing, which we were missing in in a desktop application space, let's say it that way, for a long time. So that's why I think security is one of the most important aspects what WebAssembly and especially Fuzzy brings to the table. Okay, with that, so a little bit about the background and why, let's dive into Crustlet. Okay, so Crustlet, I mean, Rainer said that there was already a talk about Crustlet, and I am sure that, for example, Ryan was here talking about Crustlet. So Crustlet is, as the name implies, it's written in Rust, right? It's basically a marriage of two things. So we have access to a WASI compliant runtime. By default, it is WASM time. And we have an implementation of one of the most prominent components of a Kubernetes environment, which is the kubelet. So in Kubernetes, the kubelet is responsible for running workloads. So basically, if we as a developers, let's say we interact with the Kubernetes cluster, and we say, hey, Kubernetes, please run that application, right? So we persist something in Kubernetes API server, so in etcd. And what Kubernetes does, it fires an event that pod is the atomic unit of work in Kubernetes has been requested. And then there is a scheduler. So the scheduler is a component in Kubernetes, which is responsible for, actually scheduling workloads to virtual machines or to nodes, to worker nodes in the cluster. And the kubelet gets a notification or reacts on the schedule and says, okay, I am aware of what I should do. So it pulls down a container image, if we speak about containers, and it runs that using containerd as a runtime. And Crustlet, with Crustlet, we get rid of containerd because we don't need containers, because we use a WebAssembly and WASM time, so the Fuzzy compliant runtime, as an isolation layer, as an application platform, right? So still, Crustlet gets the request to execute a workload. Then it somehow, we will see in a minute how, it somehow pulls that WASM module and executes it using WASM time. So that's how those two components work together in Crustlet. And on top of that, obviously, Crustlet behaves like any other, let's say, node in a Kubernetes cluster. So we can ask for logs that a workload produces. We can take a look at what makes that workload actually happen. So we can get information about environment variables, stuff like that. And we can, collect logs from the kubelet so that we can see how the overall utilization is, how the kubelet reacts to certain things like scaling and bringing on new kubelet worker nodes. Yeah, Crustlet has a flexible provider module. So WASM time, as I said, is the default runtime for WebAssembly workloads, but that can be changed. So you could obviously switch to a different WebAssembly runtime. A bit more, to when you do hands-on. Basically, Crustlet is just a binary, right? It's a binary that you can run on any kind of machine, and it brings in that compute power from that particular machine into your Kubernetes cluster, right? So we can install Crustlet in a wide variety of Kubernetes distributions. It starts small with Kint, so Kubernetes and Docker. That's what I use locally for testing or working with Kubernetes in the inner loop. Or if you grow, or if your requirements grow, you can obviously install Crustlet in regular Kubernetes clusters, or if you use a managed Kubernetes environment, for example, AKS is Azure Kubernetes Service, or the AWS or Google Compute Cloud competitors, then you can install or bring in Crustlet there too. So the question is, why Azure, right? Why should you take a look at Azure when you're focusing or diving into Crustlet? So obviously, Crustlet is an open source project, but if you take a look at the actual contributor who's maintaining the project, those are mostly full-time employees that work at Microsoft. So Microsoft has a huge interest in making Crustlet successful, because that would allow them to drive the utilization of compute resources, right? Because WASM, the WASM runtime and WebAssembly itself, I mean, we don't need any kind of Docker host, right, to run applications isolated from each other. There is the WebAssembly runtime, which is, from my point of view, so my experience is what I tested on the environments I got my hands on. It looks like it is more efficient compared to containers. And what always stands for, or for what Microsoft always stands for, is integration, right? So adding things or integrating with existing services is always top on mind when at Microsoft. So, and the same applies about how to get your hands on Crustlet. I mean, getting a Kubernetes cluster, a full-blown Kubernetes cluster in Azure takes like 5 minutes, and that's the competition, right? The competition is always between those public cloud vendors who is able to reduce the time till you can access your Kubernetes cluster. And when it comes to Crustlet, it's a one-liner. Right, you need an extension, which is currently in preview, that you can install locally if you work with Azure CLI, and then you can just extend any existing Kubernetes cluster and bring in Crustlet nodes to run your WebAssembly workloads. And another interesting thing which Microsoft gives you out of the box is the support for the WebAssembly gateway interface. So the gateway interface is basically an interface which allows you to route network calls. So for example, you can say, okay, I want something in my cluster to react to a GET request on the route /hello, and then you can point to a WebAssembly module which is responsible for dealing with that GET request. And on the other hand, you may have a post request to another route, and then you can point to a different Rust or WebAssembly module. And this allows us to, do microservices, let's say it that way, but on a way more fine granular level. right? We can, for example, say, well, this action, I can use Rust to get that up and running in minutes. And perhaps for another route, Go or C# is way more efficient to get that work done. So I can focus more on how can I achieve that that workload efficiently. I just have to compile it against WASM32 WASI. Okay, enough of slides. Let's quickly take a look at Crustlet in Azure. So let me jump over to the browser. So I've already provisioned an Kubernetes cluster. There is no Crustlet integration yet. And I've also provisioned a container registry. We will take a look at that in a second. So if we dive into the Kubernetes cluster, we can take a look at the node pools. And we see there's a regular node pool, which is running Linux. So let me quickly go to the nodes. That should be easier. So we see there is a regular Ubuntu 18.04 running, and it's able to run containers using containerd as a runtime. Okay, so what I've done, let me switch over to the terminal. Is the font size big enough? If not, just reach out in the comments, then I can bump it even more. Okay, and if you're wondering which terminal I use, so I'm always interested in terminals, I use Warp. If you know Warp, Warp is a terminal written in Rust, and I have 5 invitations left, so it's currently a closed preview. If you want one, please reach out on Twitter, so just mention @RustLinz, and we will we will raffle the 5 invitations. So someone will get access to that one, and everyone who gets access can again invite 5 others. So maybe we can spread Warp a little bit more, because I think it's a super efficient terminal. It yet has to catch up with iTerm, but let's go back to topic. Okay, so I have kubectl installed on my machine, kubectl, but I'm a lazy guy, so I have an alias k, which is kubectl. So don't, so bear with me. So I have different clusters I'm able to talk to. Let me quickly config get context, verify if I'm looking. Oops. Okay, config get context. There's an S missing. Yes, I'm looking at the AKS one. So you see over here. Let me quickly ask for the nodes. So Kubernetes, give me all the nodes, and we should see the same as we previously saw in the portal. Yes, there's one. So I've installed the extension to bring in Crustlet, right? So I can easily do AKS node pool add, and let me bring that one from the history, because that's easier than remembering the name of my resource group. So what I basically can say, hey, there is an existing Kubernetes cluster with that name and that resource group. Please create a new node pool. A node pool is like a logical construct. So technically, it's a virtual machine scale set. And I say, in that scale set, please provision 1 VM. And hey, please use WASI as the workload runtime. Okay, so it's a one-liner. Let's give it a shot. And we see, okay, that's part of the preview extension that you have installed, and in a couple of minutes we should be good to go. But let's keep that running over here, and let's move on to the Crustlet side. So this is the official Crustlet website, so crustlet.dev, and maybe I don't know when the meetup was, when the guys from the team were talking about Crustlet. So we saw a lot of improvement when it comes to onboard Crustlet, so to bring Crustlet into your environment. Obviously, there was Crustlet had that momentum when they released the first major version, and then there was Ignite when Microsoft announced a preview for Crustlet and ACAS. So if it has been a while since you double-checked the guides, give it a shot. They improved massively in the last weeks or so. Okay, so I think it should be up and running. I don't know, it takes a while. I'm not good in waiting at something. So let's move on to Visual Studio Code. We can revisit that in a second. So the question is, how can we get a WASM module? Obviously, we can use Rust up to bring in WASM 32 WASI as a target, and then we can compile against that one. So I have two really fundamental samples, right? So it's nothing fancy here, right? We have a WASM workload which is doing nothing than, you know, just in an endless loop printing information to an to the standard output, right? So nothing fancy here. So I can compile that one obviously against the WASM platform. Let me go to Hello Crustlet and let's say cargo build, and let's say I want to do the release build and I have to target for our desired platform. All right, so that one is built. Obviously, I didn't do any change, so I can run that using WASM time run target. Then there is this one, there's this one, and there's my WASM module. And as you can see, every 750 milliseconds, hello Crustlet message will be printed to the standard output. So having a WASM module, we can leverage every OCI distribution spec compliant container registry. So basically every Docker registry that's able to deal with OCI, Open Container Initiative artifacts. Because we can take a WASM module and just push it to that registry. So we have a secure and obviously on most situations, a trusted distribution channel, which is really important. So I have previously published, let me go to the resource group, a container registry. So the question is, how can we get the WASM module as an OCI compliant artifact to our ACR, so our Azure Container Registry? And there is, as always, there's a small tool that's called WASM to OCI, which is just a CLI that we can use. Let me switch back to Visual Studio Code. Let me go into target release and target release, target WASM 32 release. So here's my WASM module, right? So hello Crustlet WASM. So I can use OCI to WASM. Isn't that then my path? No, WASM to OCI, obviously. Push, and then I can say hello crustlet.wasm, and I just have to provide a name how that artifact should be called or should be persisted in my Azure Container Registry. And Azure Container Registry has a requirement that you have to fully qualify your artifact. So it's always your individual name of your ACR instance .azure.cr.io, and then you can obviously specify the name of that artifact or of the repository. Let's say hello rust dash, and we give it a tag of o.o.1. Hopefully the token is still valid, and yes, it pushed it, so we can see we should be able to find our WASM module, and there's hello Rust Linz in the container registry. And from there, Crustlet is able to pull that workload. So how can that be pulled? Because ACR obviously requires some kind of authentication. And as of today, we have to specify credentials for that container registry as a in Kubernetes as a secret, right? It's so-called image pull secret that we can then list on the actual pod, so on the vehicle that we use to run our workload. Azure does a great job in integrating things, as I mentioned earlier, right? So normally what you can do when you rely on containers, you can just, say, hey, this AKS, so my Kubernetes cluster, can leverage so-called managed service identity with role-based access control to pull, so to download things from that container registry. That does not work with Crustlet yet, hopefully yet. So we have to specify, we have to persist a Kubernetes, a special kind of Kubernetes secret in the cluster that that Crustlet is able to take into consideration in order to pull that WebAssembly module from Azure Container Registry. Okay, so we have a workload in our container registry. Let's jump back to the terminal, and there we go. We onboarding a Crustlet in AKS worked. So we got a not so good looking table output over here because there's so many metadata involved. So let's dive into the cluster itself. Let's say kubectl get nodes. And you see right now I have a WASM WASI pool with a VM there running in version 1.0.0 alpha 1. And if we dive into that one, so let's say kubectl describe node, like that one. Let's go scroll a little bit up there. We see a bunch of labels and taints being assigned to that particular node. And in contrast to regular container-based nodes, let's say it that way, we see that the architecture is set to WASM 32 WAGI. This is specific, or this is true for AKS. If we bring in Crustlet to other Kubernetes distributions, as we will do in a second, there will be WASM 32 WASI. So this is a value add from Azure again, that we get the WebAssembly gateway interface on top for free, right? So that we can leverage, or we can run workloads as responder to HTTP calls and stuff like that. So that was the good story about the actual state of the preview. The bad story is I reached out to Rainer yesterday and said, okay, I'm not able to run the simplest ever WASM module currently in AKS with Crustlet. So unfortunately, there seems to be some kind of misconfiguration. Maybe it's due to my Kubernetes cluster, but I spun up another one. So I was not able to get it up and running in AKS. However, I have other Kubernetes clusters, right? And it's not about Azure today. It's about Crustlet and Kubernetes. So let's say config get context and texts. And let's quickly switch over to kubectl config use context kind. So I have a kind cluster running locally in my, in my Docker desktop environment. So I have Docker running locally. And if I do kubectl get nodes right now, you see I have just running a control plane. There's and a master, obviously. So there's nothing installed yet. There's no Crustlet. And what I have is I have a Crustlet folder. And I've downloaded, according to the official documentation, I've downloaded the Crustlet the Crustlet binary that I can use to bring in my compute power so that WebAssembly workloads got executed on my machine, right? So what I've done, I've also downloaded the Bootstrap script, which is a shell script that takes care about, building a Crustlet configuration for your needs. So that's estimates the current Kubernetes, the kubectl context, and based on that, it creates, let's say, config file, which is located in config-bootstrap.conf. And as you can see, there is a certificate, for doing TLS-based authentication between the Crustlet and the Kubernetes cluster. And that's everything over here is obviously tied to the Kind cluster I am looking at right now. So I've downloaded the Crustlet binary. So that's Crustlet Vazi. And upon Bootstrap, I have to provide that config. So again, download Crustlet, the binary, download the Bootstrap file, run the Bootstrap file, and then we use that output, so the generated bootstrap.conf, in combination with the binary to bring in our own Wasm Vazi node into the Kubernetes cluster. Let's do that. And there we go. Yeah, there is some workloads that are obviously container-based, so that is not able to be executed in Crustlet. So let's go to another terminal instance, and let's again do a kubectl get nodes. And as you can see, that's the host name of my machine right now being available as a node. So with that, let's bring some actual workloads to that cluster. So before I forget, I mentioned about how to make Crustlet able to pull Docker or to pull WASM modules from the Docker registry, so from the private Docker registry, right? So I have to provide credentials, and I have stored them over here. So that's a regular Kubernetes secret, cut ACR pull creds. So that's just a base64 encoded representation of that Docker config JSON, which is basically telling, okay, there is an ACR instance running at my individual name.azure.cr.io. Use that username and use that password in order to pull down OCI compliant artifacts, no matter if it is a Docker image or no matter if it is a WebAssembly module, right? So let's install that in double quotes in Kubernetes by saying kubectl. I should just write K, right? kubectl apply -f. That's called ACR pull creds. Okay, and with that, you see secret ACR created. So let's verify that one. K get secret. And you see, okay, that's in the default namespace because I didn't specify any kind of namespace, and then all my queries run to the default namespace in Kubernetes. All right, so back to VS Code. We have our workload over here. I have a Kubernetes folder because I want to structure, the deployment manifest and stuff like that a little bit. So let me quickly bring in pod. So pod is the smallest unit of work in Kubernetes that we use to run workloads. Hello Crustlet was that. And then we specify our image that was Wasm beyond the browser.azure. Oh, let me copy that one. So if I do a mistake over here in the name, then demogods will not be good to me. Okay, we have to specify some resources. That's totally optional, but definitely one of the most important things to do in Kubernetes. So let's say our app needs memory because it's super complex, right? It needs 16 megabytes of RAM, and it needs, let's say, whatever I had, it needs 5 milli CPUs, or let's say 10, be on the safe side. And if our WASM module takes more than, let's say, 32 megabytes of RAM, or it takes 25 milli CPUs, then something is not right? And then Kubernetes should kill that thing and start it up again. So important not to forget, I have to, we don't need ports. We need, obviously, on level of containers, we need image pull secrets. And the name of that one was specified as ACR. So that is normally, that's all you have to do to run a workload in Kubernetes. But we have multiple nodes, right? There was that one node which is able to run containers, and there's our crustlet, and we have to target crustlet. And if you remember, we looked at AKS over there. We looked at AKS and scroll up, and we have labels and we have tains over here. And let's revisit those tains in our this thing, kubectl get nodes, and let's grab the host name and let's say kubectl k describe. I think I have to add, describe node. And now, not running in Azure, you see we have WASM32 WASI. We don't have WAGI. We don't have the network gateway interface. Okay, so we can add so-called tolerations to our workloads that say, hey, please target a specific thing. So in our case, we want to target nodes with WASM32 WASI. Okay, let's save that one. That's everything we need to specify in order to target that workload always and only to nodes running crustlet. Okay, let's go there. Let's go in the other folder that was CD001 hello crustlet. Let's clean up the thing and let's say kubectl apply from file, and that is pod. Oh no, it's Kubernetes pod.yaml. Error validating, did a mistake. Resources, did a mistake. It is request S. That's plural. Oh, and I did another mistake. Okay, so now we go. There we go. CPU. Okay, there we go. So let's double check. kubectl get PO, so give me all the pods, and we see, hey, this one is already running, and let's give out some more information. And we see it's running on my machine. So if I go back to this one, so where the crustlet is running, I see, okay, there's no output yet, so that looks pretty good. Let me get some logs, kubectl logs, and I can provide the name of the pod, which is hello crustlet. And as you can see, there have been generated a bunch of logs already. So that is the most simple, or the simplest workload we can run with WebAssembly in Kubernetes. But typically, applications need to interact with things, right? They need to interact, for example, with the file system. Again, pretty similar, very easy application. It's just taking a configurable target, which is a folder, right? And then every now and then, so basically every 2 seconds, it's writing a file to that particular folder. And the file is just a random, it's just the iteration. So in int32 that gets increased every time, and then I'm writing instant now. So milliseconds since I don't know what it is, first of blah, 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 90 something to that file. So that doesn't matter. It's more the fact of, interacting with the underlying operating system API. And this has to go through WASI. Let's quickly go up into that folder, CD002. I have to hurry up a little bit. And let's say, clean up that thing, wasm time run dot slash target slash wasm WASI target, now release hello WASI, and let's, that was right, so let's provide a -env, let's say target equals, let's say slash users slash Thorsten slash desktop. Okay, so I set the target, that environment variable for the particular WASM module to that folder. So the application should write files onto my desktop, right? Let's invoke that one. Oh, it's --e. There we go, and we got panic because WASI protects our system resource from being accessed by that WASM module. What we typically do with WASM time is we have to provide it access to that folder by specifying it using the dir argument. So let's say users Thorsten, and let's use downloads. Let's change that. It's not desktop, it's downloads. With that, the apps keep running, and it will. Let's kill that thing, and let's do a list all files of my downloads folder. And as you can see, there is the file there are 3 files already being created. So basically, I have to bring in or to allow that module access to certain file locations, to certain operating system APIs that I want that application to leverage, right? And this is a concept we can super easily adopt in Kubernetes. Because if we take a look at the pod spec, let me quickly bring up just a template. And what we can do, we can take something that's called volumes, right? So we can bring in persistent storage. For example, let's say, I don't know, sample, and a sample can be, oops, over there, that can be an Azure disk, Azure blob storage files, you name it, right? AWS Elastic Blob Store, whatever. That could be a iSCSI storage available in that network. Or in our case, if we run in Kint, so let me bring in the actual manifest. So what I do over here, I specify a pod called hello WASI and reference it again from the same ACR. I set the target, so the target environment variable to mount/data. And mount/data comes from something that's called volume. And the volume will allow that particular WASM module to have access to the out folder sitting here in VS Code, so we can easily verify if everything works as expected. And again, we have those tolerations to ensure that our workload will be executed on Crustlet instead of the regular Kubernetes nodes. So let's go to cd Kubernetes, where there's the pod file, and let's say, hey kube, apply a thing, and that's created, and you see logs popping up over here. And we should also see, if we say kubectl to give me all the information, and you see this one is running since 30 seconds ago, and it's also running on my Crustlet machine. Okay, so we are able to integrate seamlessly and to fine granularly control what the WASM modules are able to do in Kubernetes by leveraging first-class, or first-class citizens like storages or volume mounts. Okay, with that, let me quickly switch back to the slides because we have to catch up with the slides a bit. As I said, okay, in AKS, the actual combination of AKS and Crustlet did not work for me, and I tested it yesterday, I tested it today, and then I decided, okay, let's go with Kint, because otherwise we could also have had a look at the WebAssembly gateway interface to, route HTTP requests to WASM modules, which is typically what I do in my day-to-day life. I deal with web APIs. And yeah, so obviously what you have to do, you need access to some kind of OCI distribution spec compliant container registry. I use Azure Container Registry all the time. I'm loving it. I'm loving the experience they provide. And you have to add that platform to your toolchain. And then you have to build against WASM32 WASI. Yeah, we looked at very simple workloads, how to invoke them on using Crustlet on Kubernetes, which brings me to the conclusion. So I think Crustlet obviously is better than containers for when it comes to resource utilization. Is that something I have to care about? Well, obviously not from a hosting perspective, because most of my workloads are running in the public cloud, but from monetization perspective, because if I can add more workloads to the same amount of compute power, I can run, or I can leverage, or I can deal or serve to more customers with the same amount of money. So yes, at some point it becomes interesting. I think the benefit is not that huge enough to see the effect for smaller applications. But what I really like about that fact is that we can now fine granularly leverage or provide permissions, or bring permissions to certain service or individual workloads. So basically, it will enhance the overall security and robustness, because I can specify, okay, this workload is able to do X, Y, and Z, whereas the other one isn't. And to be honest, from my point of view, it is still a bit early. And I got that, yes, AKS and Crustlet, I didn't get it up and running. I SSH'd into that node that is actually running Crustlet, and I was not able to spot the error. So it is still early. And right now, my point of view is I would rather go with a virtual machine scale set in Azure, for example, and bring in Crustlet using desired state configuration on my own. But then I have full control over the Crustlet, right? So as I have it on my machine, right? You saw I just fired up that binary, and I was able to integrate that one as a node into my Kubernetes cluster. So if I go that direction, it would be more beneficial when it comes to troubleshooting or actually investigating and seeing what's going on behind the scenes. So that's my take for the current state of Crustlet. I bet it may become not the most popular or not the most prominent runtime in Kubernetes, but it will be place 2. So I don't think that we will get rid of containers all over the place and everything will be WebAssembly. That could be true in a couple of years, perhaps 5 years or in a decade. But as we talk about Kubernetes today, I think WASM will be on the second place but hopefully at some point feature compliant with containers. And with that,